Hello, Math 3, and welcome to Lesson 2 of Piecewise Functions. Today we're going to talk about evaluating with piecewise functions, something that you probably already experienced in the first lesson, but we want to make it a little more clear. So first thing I wanted to clarify from the first lesson is that a piecewise function, again, can have many pieces. And I wanted to show you that piecewise functions aren't just linear. So I provided a piecewise function here with a constant function, a quadratic function, and a linear function as its third part. It can have multiple parts. The only thing that you want to watch out for is make sure that the parts do not overlap and end up failing the vertical line test. So you can see that this function actually, well, it is a function because it passes the vertical line test. So here are the three pieces. It is y equals, or f of x equals -2, f of x equals x plus 2 quantity squared minus 4, and f of x equals 2x minus 4. Those are the three pieces. And I've defined a domain for each one of those three pieces. And you can, I encourage you at this point to maybe pause the video and copy down this function. It's really good to get hands-on with it and put it into your notebook so that you can see how each one of these behaves. Okay. So anyway, those are the pieces. We got some critical points. The endpoints are very important. You got an open circle, closed circle, and an open circle here at the end. And each one of those is open or closed for a reason, and that's due to the inequalities that, again, you can see when you look at the domain for each part. We're going to talk more about the evaluations, though. So I'm going to show you how to find how to evaluate with these functions in two different ways. First, let's go over this graphically. F of -5. If I want to find f of -5, I'm going to go to my input -5, and I'm simply going to find my output. And it looks like my output at -5 is exactly -2. All right. F of -3, again, I'm going to look at the graph. I'm going to go to -3, and it looks like I have two possibilities. However, the first one is an open circle, meaning it is not contained in that section. So it looks like our output at -3 is going to be also -3. Y equals -3. All right. So I'm gathering that just by viewing the function, just by looking at it. F of 0, I'm going to find the output at 0. It looks like the output is 0. All right. F of 1, again, I go to my x-axis, I look at 1, and I find the output. The output at 1 is exactly 5. So f of 1 is 5. All right, et cetera, et cetera. Here's a tricky one. I can go to f of 2, and when I look at f of 2, there is no closed circle anywhere for an input of 2. So f of 2 is what you would call undefined. F of 4, well, I look for input 4. Look for my output. It looks like my output is actually 4. All right. And so that's how I evaluate. I can evaluate for my right-brained visual learners. You can evaluate by looking at the graph. You need to know how to evaluate quantitatively, though. All right. So we need to know how to do this without looking at the graph and by looking at the equations. So f of -5. We learned in Math 1 that to evaluate, you simply substitute the input into the function. Well, the problem with piecewise functions is they have this one has three different functions. So where do I substitute it? Well, f of -5, if -5 is my input, I need to look at my domain and see in which of my domain intervals, this is important, in which of my domain intervals is -5 contained. So -5 is a value that is less than -3, meaning it is contained in the first part of the function. Therefore, I'm going to substitute -5 into the first function. Well, it doesn't even have a place for an input. The output's always -2. So there it is. All right. For f of -3, again, I'm going to see which of my domain intervals contains -3. Well, it's my second one because it has x is greater than or equal to -3. So that means the input -3 is utilized in this function. I'm going to use mental math for this. All right. But I will write it down. All right. So it's quantity -3 plus 2 quantity squared subtract 4. So -3 plus 2 is -1. -1 quantity squared is 1. 1 minus 4 is, guess what? -3. So we have, that is -3. All right, so we end up getting the same outputs by using evaluations. Again, the key is with your x value, your input, find which function it's supposed to go into depending on its domain interval that's specified after the function. So that's it. That's how you evaluate both graphically and quantitatively.